Hello there, and welcome to the Sleepy Narrator, where wonder gets cozy and science takes the long, scenic route towards sleep. Tonight's calm journey explores one of the most puzzling forces we rely on yet hardly comprehend: time. It slips right past us, shapes our days, and now and then plays little tricks, especially when you're staring at a kettle, waiting for it to boil. But before we start unraveling the mysterious weave of time, I'd love to know, where in the world are you watching from? And what's the time for you at this moment? Quite fitting, isn't it? A video about time, and yet here we are, scattered across various time zones, all arriving here together in our own slice of the ticking world. If you find this journey soothing, interesting, or just a comforting way to wind down after a busy day, I'd be very thankful if you tapped like or subscribed. It helps this small, peaceful corner reach others who could use a little quiet too. Now, I hope this isn't so fascinating that it keeps you wide awake. But if it does, at least you'll learn a little something about the structure of the universe before drifting off. So make yourself comfortable, ease your thoughts, and let's begin. Because somewhere between ticking seconds and sweeping centuries, between dreams and daylight, lives the tale of time. Time has a peculiar way of expanding and shrinking, doesn't it? 10 minutes in traffic can feel like forever, while 10 minutes spent doing something you love vanishes quicker than the last cookie in the jar. Yet clocks keep moving at a steady rate, second by second, minute by minute. So what's happening? The answer doesn't start with physics, but rather in your mind. How we perceive time, that internal sense of when things begin and end, is surprisingly bendable. Psychologists refer to it as subjective time, and it's heavily affected by attention, emotions, and memory. In other words, how time feels to you can be quite different from how it's actually passing. Let's begin with the strangeness of waiting. Picture yourself in a doctor's office. The walls are a dull color, the magazines look ancient, and the clock ticks in the corner like it's trying to win the world record for annoyance. Just 5 minutes can feel like half an hour. That's because your brain isn't getting enough stimulation. When there's not much happening, your focus turns inward and you start noticing each tick more clearly. Now compare that to a lively conversation with a friend or being absorbed in a great story. In those instances, you're fully engaged and your brain stops monitoring time so closely. It's like your mind says, "We're busy, no need to keep track." And before you know it, hours have slipped by. This is sometimes described as being in a flow state, a term introduced by psychologist Mihaly Csikszentmihalyi, when your awareness of time fades because you're entirely in the moment. What's more, new experiences play a role. When you encounter something unfamiliar, your brain uses extra effort to process and store it. Later on, when you remember it, it seems like more time must have passed because there's more mental footage to review. This helps explain why childhood summers feel so long. Your young brain was constantly dealing with new things, logging every moment in detail. But as we grow and settle into routines, our brains get more efficient. They compress memories. Fewer highlights, shorter memory reels, and suddenly time feels like it's moving faster. Emotions influence time, too. Studies show that fear and anxiety can make time feel like it's crawling. On the other hand, joy and excitement can make it race by. Some researchers even suggest that in intense or dangerous moments, your brain forms denser memories, making it seem like time has slowed. People often describe this after car accidents or emergencies. It's not that time is really slowing, it's that your mind is capturing more detail per second, which later plays back like a slow-motion scene. Then there's boredom. You've likely heard the saying, "Time flies when you're having fun." And the flip side is true too: time drags when you're bored. Neuroscientists discovered that during boredom, the brain's internal pacemaker becomes more active. Yes, that's an actual term. This internal rhythm produces more perceptual pulses, making time appear to stretch out. Like having an overly enthusiastic drummer in your head tapping out every dull second. Our cultural background and the language we use also shape how we understand time. In English, We talk about time like it's a currency. We spend it, save it, and sometimes run out of it. But in other languages, like Hopi, time isn't treated like a straight line. Instead, it's more like a landscape or a set of conditions. This shifts how people from different cultures think about both the past and the future. In some cultures, people point behind them to represent the future because it's unseen, and ahead to represent the past because it's known. The exact reverse of what most of us imagine. But what about our internal clocks? Surely there must be some kind of biological system ticking along, giving us at least a rough sense of time. There is sort of. Humans operate on what's called a circadian rhythm, a roughly 24-hour cycle that helps regulate sleep, body heat, and hormone levels. But that's more like a daily alarm than a stopwatch. For shorter spans, seconds or minutes, scientists believe we use a kind of mental timer. It's often likened to an internal stopwatch and involves various parts of the brain, including the basal ganglia and the cerebellum. This system relies on a regular pattern of neural pulses. When we try to estimate how long something lasted, we're subconsciously tallying those pulses. But we're not exactly experts at it. Our time guesses can be way off, especially when we're distracted, multitasking, or emotionally stirred. There's even something known as the return trip effect. You may have felt it. The journey home often feels shorter than the trip to your destination, even if they took the same time. Why? On the way there, your brain is processing lots of new data. On the return, it already knows the way, so the experience feels quicker. And let's not skip the most universal time distortion known to people everywhere, the snooze button. Those 9 minutes between alarms somehow feel shorter than any other 9 minutes on Earth. While there's no solid scientific explanation for that exact sensation just yet, it's likely another case of broken sleep, semi-consciousness, and your fuzzy inner clock just throwing up its hands and giving up. So what is time, at least the way we experience it? It's more than just a number on a screen or the shadow sliding across a sundial. It's a sensation, a perception, a trick shaped by memory and attention. It shifts with our feelings, our age, and even the language we speak. It speeds up when we fall in love, slows down when we're afraid, and at times seems to disappear altogether. And while physics might someday explain what time truly is on the largest scales, our personal experience of time will always remain deeply human, wobbly, unpredictable, and in its own way, quietly remarkable. If time is mysterious, then our attempts to track it are a testament to human creativity and, let's be honest, our impatience. From ancient shadows to ticking atomic precision, we've spent ages trying to capture this invisible flow and make it something visible, countable, and ideally, something we can schedule. Because although time waits for no one, people really love to ask it to hold on just a second. Let's go back, way back to the earliest days, when the first timekeepers weren't made of metal or glass, but of sky. Our ancestors were incredibly skilled observers of the heavens. They watched the sunrise and sunset, the phases of the moon, and the gradual turning of seasons. These natural cycles became the earliest calendars, no batteries needed. The ancient Egyptians were among the first to formalize the way we kept time. Around 1500 BCE, they constructed towering obelisks that acted as giant sundials. By watching how the shadows moved, they could break daylight into parts. Sure, the length of those parts changed with the seasons. An hour in summer was longer than one in winter, but it was enough to help with farming, religious rituals, and community organization. And even then, people were probably already running late. Then came water clocks. Used by both the Egyptians and later by the Greeks and Chinese, these devices tracked time by letting water drip or flow steadily from one container to another. They were basic but reliable, and unlike sundials, they worked at night. Some were surprisingly intricate, with gears and carved figures that rang bells or marked the hour. You could think of them as the original smart devices, only a bit soggier. In Mesoamerica, the Maya developed incredibly advanced calendar systems. They tracked solar and lunar cycles with remarkable accuracy, and their long count calendar could measure spans of thousands of years. All this from a society that didn't use metal tools or have beasts of burden. Their understanding of time was nothing short of cosmic. Back in Europe, mechanical clocks didn't really appear until the Middle Ages. At first, they were massive and bulky, usually mounted in church towers or monasteries. They didn't have hands or faces, just bells that rang out regularly to remind monks when to pray. You could say monks were the first alarm clock users, though probably more peaceful about it than most of us are at 6 in the morning. One of the big leaps forward came in the 14th century with a clever invention called the verge escapement. This allowed energy to be released in a more controlled and consistent way, making it possible to build smaller and more accurate mechanical clocks. Eventually, clockmakers added dials and hands so people could see the time, not just hear it chime. From there, innovation picked up speed. By the 17th century, the pendulum clock was introduced, thanks to Dutch scientist Christian Huygens. These clocks were accurate within a minute per day, an amazing improvement over earlier clocks that could drift by hours. If time was like a horse, the pendulum was the saddle that let us ride it with confidence. The need for even greater precision became vital during the age of exploration. Sailors had to know their longitude, and that required knowing the exact time at a reference point, like Greenwich. Enter John Harrison, an English carpenter who dedicated decades of his life to solving this problem. He created marine chronometers, extremely precise clocks that could survive the constant rocking of a ship at sea. His fourth design, the H4, changed navigation forever and eventually earned him long overdue recognition. Also, possibly some side eyes from sailors who had been using stars and gut feelings up until then. By the 20th century, we entered the age of quartz. Quartz crystal oscillators, developed in the 1920s, transformed how we measured time. When an electric current is applied, quartz vibrates at an incredibly stable frequency. These tiny vibrations were used to keep time far more precisely than any mechanical system. Suddenly, watches and clocks became portable, affordable, and reliable enough to keep trains running. Well, at least to give us fewer excuses when they didn't. But even quartz has its limits. If you're looking for the most precise time on Earth, you'll need to go atomic. Atomic clocks, introduced in the 1950s, measure time using the natural vibrations of atoms, usually cesium or rubidium. A cesium atom, for example, oscillates exactly 9,192,630,1770 times per second. That number isn't just trivia. It's the official definition of 1 second according to the International System of Units. These clocks are so accurate that if one ran for 100 million years, it would be off by less than a single second, which is perfect, assuming you're planning to steep your tea for the next 100 million years. Today, atomic clocks are used to keep everything synchronized, from GPS satellites to internet servers, telecom systems, and the global financial network. Without them, your phone's maps wouldn't function, your bank transactions would be a mess, and half the world might miss their video meetings. Time, once tracked by dripping water and shifting shadows, is now tied to atoms bouncing like tiny metronomes in sealed, high-tech laboratories. And yet, despite all this precision, time still feels oddly personal. We can divide it into minutes and hours, watch it scroll across digital screens, but no matter how closely we slice it, we each live it a little differently. So why did we start measuring time in the first place? Some suggest it began to regulate religious practices. Others believe it was for farming, keeping track of the seasons, or organizing trade. But maybe, just maybe, it's because humans, with our love for rhythms and stories, feel comforted by pattern. That gentle beat of time, no matter how elusive, gives structure to our days. It brings order to the chaos. A tick, a tock, a tiny whisper from the universe saying, "You're here now." And for most of history, time wasn't some universal constant. It rose with the sun, faded with the stars, and meandered through the hours guided by bells, bird songs, and maybe a slightly too enthusiastic rooster. But then came Isaac Newton, a man not content with simply describing the world. He wanted to lock it down, and that included time. Newton, the 17th century English physicist with famously wild hair and a knack for turning apples into metaphors, gave the world a model of the universe that reigned supreme for over 200 years. In Newton's view, space and time were like an invisible, unchanging stage. The action, planets, apples, cannonballs, bicycles, all took place on that stage. But the stage itself, always steady, always the same. Time in this vision was absolute. It ticked forward at the same rate for everyone everywhere forever. He even wrote, absolute, true, and mathematical time of itself and from its own nature flows equably without regard to anything external. In simpler terms, time is like a river that flows evenly, whether or not anyone's watching it, or floating along in a canoe. It felt intuitive. Drop something today or tomorrow, here or in another city, and Newton's math could tell you exactly where it would be at any moment, assuming you had enough patience and coffee to do the calculations. Time became the background, the steady drumbeat for motion, force, and gravity to do their thing. And Newton's absolute time gave scientists a powerful framework to work within. They could synchronize clocks, predict orbits, and build machines that operated with incredible precision. It made sense, at least on the surface. But it also came with a major assumption, that time was a thing all by itself, that even if nothing was happening, time kept flowing. Not everyone agreed. The philosopher Gottfried Wilhelm Leibniz, Newton's intellectual rival and co-creator of calculus, wasn't convinced. Leibniz argued that time isn't a separate thing, it's just a way we describe change. If nothing happens, there's no time to talk about. He challenged the idea of a clock ticking in an empty universe. For Newton, that clock still measures time. For Leibniz, it's just a silent lump with no one to notice it. Newton didn't back down. He insisted that time flowed independently of events, which, let's be honest, does sort of line up with how it feels when you're waiting for your food to heat in the microwave. Newton's model eventually became the backbone of what we now call classical mechanics. And for a very long time, it worked incredibly well. It could describe falling objects, swinging pendulums, planetary motion, even the wobble of a unicyclist juggling fruit, all based on that stable backdrop of absolute time. It's worth pausing here to appreciate just how successful Newton's vision was. For centuries, scientists used it to explain nearly everything they could observe. Clocks grew more accurate. Navigation became reliable. Engineering advanced. Trains ran more or less on time, or at least had better excuses when they didn't. But eventually, Newton's version of time began to crack under pressure. In the 19th century, scientists investigating light and electromagnetism started noticing something odd. Experiments revealed that the speed of light always seemed to stay the same, no matter how fast the observer was moving. That didn't make sense in Newton's universe. If you're in a car chasing a beam of light, you should catch up to it at least a little, right? But that's not what they observed. Light always zoomed away at the same constant speed. This strange puzzle lingered for a while, until a young patent clerk named Albert Einstein entered the scene. But we'll save his full introduction for a bit later. For now, it's enough to say that Einstein would take Newton's tidy picture of absolute time, give it a respectful nod, and then turn it entirely upside down. Still, Newton's idea, that time is an ever-flowing, universal stream, left a lasting impression, both in science and everyday life. We still speak about time as if it's a substance, something you can waste, spend, or save. We treat it like money, slipping through our fingers unless we use it wisely. And in many day-to-day situations, Newton's version works perfectly well. When you're baking a cake, catching a bus, or figuring out when that online order might arrive, absolute time gets the job done. It's only when we venture into extreme territory, really high speeds, massive gravitational forces, or tiny quantum scales, that Newton's model starts to blur. So in the vast story of time, Newton gave us a strong middle chapter, a world that ticked like clockwork. He brought a kind of order to the universe and made time something we could measure, trust, and if only briefly, understand. But time, as it turns out, has more than one personality. If Newton pictured time as a river flowing smoothly and evenly, Albert Einstein came along and suggested, actually, it's more like a stretchy, flexible trampoline. Not his exact words, but not too far off either. In the early 20th century, Einstein shattered our ideas of time and space with a theory so radical, it reshaped the very structure of reality. He called it relativity, and it came in two parts: special relativity and later general relativity. Both had a lot to say about time, none of it simple, none of it easy to grasp, but all of it deeply transformative. Let's begin with special relativity. Published in 1905, when Einstein was just 26 years old and working at the Swiss Patent Office, probably scribbling down equations during lunch breaks, it changed physics forever. One of its core ideas is this: the laws of physics, including the speed of light, are the same for all observers, regardless of how fast they're moving. That's where things start to get weird. Because if the speed of light always remains constant, then space and time can't be fixed. They have to bend. Imagine two people moving at different speeds. In Newton's universe, they agree on when things happen, but in Einstein's world, they might not. Events that look simultaneous to one person might not seem that way to someone moving differently. That leads to a remarkable effect called time dilation. Put simply, the faster you move, the slower time passes for you relative to someone who's standing still. So, if you were to hop aboard a spaceship and zoom through space at near the speed of light, your clock would tick more slowly than one back on Earth. You'd age more slowly, grow your hair more slowly, and possibly miss entire seasons of your favorite shows. And this isn't science fiction, it's real. It's been tested and measured. In one famous experiment, scientists flew very precise atomic clocks around the world on airplanes. When compared with identical clocks that stayed on the ground, the ones in the air had ticked just a little bit more slowly. Not by much, but enough to prove the point. This effect is at the heart of what's known as the twin paradox. Imagine two identical twins. One of them goes on a high-speed journey through space. The other stays home, waters the plants, and waits. When the traveling twin returns, they're younger. Not because they took great care of their skin, but because less time actually passed for them. Their journey involved real, measurable time dilation. It's not a contradiction. It's a feature of relativity. A weird, unintuitive, but completely real feature. And speed isn't the only thing that warps time. In 1915, Einstein expanded his theory into something even more profound: general relativity. This new version included gravity, and showed that gravity, too, can distort time. In general relativity, gravity isn't described as a force. Instead, it's a warping of spacetime caused by mass. The more mass something has, the more it curves the space and time around it, like placing a heavy ball on a soft mattress. If time were painted on that mattress, it would stretch and twist along with the surface. That means, the stronger the gravitational pull, the slower time flows. So if you stood next to something incredibly massive, like a black hole or even a very full suitcase, time would tick more slowly for you than for someone farther away. Again, this isn't just theoretical. It's been measured. In one experiment, scientists placed two ultra-precise atomic clocks at different heights, one at the base of a mountain and one at the top. The clock lower down, closer to Earth's center of gravity, ticked a little more slowly. Even a difference of a few centimeters can cause a slight change. So technically, your head is aging faster than your feet, just a little. This strange phenomenon, gravitational time dilation, has real consequences. For example, the GPS satellites orbiting Earth experience both types of time warping. They're moving fast, so their time slows down. but they're also farther from Earth's gravity, so their time speeds up. To keep your phone's navigation accurate, those satellite clocks have to be adjusted constantly to account for both effects. Without those corrections, your location could be off by several kilometers within minutes. Time doesn't just pass, it bends and wobbles, and technology has to wobble along with it. So, what does all of this mean? Einstein showed that time isn't a fixed, universal stream. It's more like a flexible fabric, woven together with space. It can stretch, compress, or twist depending on motion and gravity. That means your time, your personal experience of now, depends on how fast you're moving and how close you are to massive objects. It's a bizarre idea, but also strangely poetic. Time is no longer the same for everyone. It's individual, relational, a little like your preference for tea or the temperature you set your shower to. Einstein's work didn't just rewrite textbooks, it changed how we understand reality. Time isn't the neutral stage it seemed to be. It's part of the dance itself, swaying, stretching, swirling with matter and motion. And even though most of us never feel these effects in daily life, every moment we experience is touched by them. So the next time someone says they're running out of time, you can gently point out, actually, time is running out differently, depending on your speed and your proximity to gravitational mass. Then smile and maybe step back. Let's imagine, just for a moment, that you wake up one day and everything around you starts running in reverse. Your toast leaps out of your mouth and lands butter side up on the plate. Your tea gets warmer as you sip it. Raindrops rise from the pavement and float back into the sky. It's strange, certainly. But is it truly impossible, at least according to the rules of physics? Not exactly. This playful little scenario leads us into one of the most compelling mysteries in science. Why does time seem to have a direction? Most of the fundamental laws of physics, from Newton's equations to the formulas of quantum mechanics, don't actually care which way time moves. They work the same forward and backward. If you filmed two particles bouncing off each other and played it in reverse, the physics would still check out. No rules would be broken. The equations would nod along silently. And yet in our daily lives, time doesn't behave like that. Eggs break, but they don't unbreak. Paper burns, but ashes don't reassemble into notebooks. We remember the past, but not the future. So where's the disconnect? Why does time feel like a one-way street? Enter the idea of the arrow of time. The arrow of time is a metaphor for the clear direction in which time seems to move, from the past toward the future. And the key to understanding it lies in one of the most important and occasionally untidy laws of physics, the second law of thermodynamics. This law says that in a closed system, like, say, the entire universe, entropy always increases over time. Entropy is a measure of disorder or randomness. In simpler terms, things tend to go from neat to messy. You can scramble an egg, but you can't unscramble it. You can clean your desk, but unless you keep tidying, it naturally gets cluttered again. And socks, they'll always vanish mysteriously, but rarely reappear in pairs. This tendency toward increasing entropy gives time its direction. It's what makes us experience events in a particular order. The low entropy past becomes the high entropy future. And there's no rewinding, unless you're a fictional wizard or a time traveler with a very specific machine. Let's put it another way. Picture a glass falling and shattering on the floor. That's a high entropy moment, shards spread everywhere, energy dispersed. Now ask yourself, what are the odds that all those shards would spontaneously jump back together into a perfect glass? Not impossible, technically, but the odds are so incredibly low, astronomically low, that we consider it impossible in practice. That's the essence of the arrow of time. The fundamental laws allow for both directions. But probability, the overwhelming tide of disorder, pushes everything one way. This leads to one of the biggest puzzles in cosmology. If entropy always increases, then that means the universe had to begin in a state of incredibly low entropy, a sort of cosmic tidy drawer before everything got messy. So, why was the early universe so neat? That's still one of physics' great unanswered questions. Some scientists think the answer lies in the geometry of space itself. Others wonder if we're even asking the right question, like a fish trying to understand what water is. And the arrow of time doesn't stop at thermodynamics. There are other arrows, too, and they all point in the same direction. There's the psychological arrow. We remember the past but not the future. Why? Because memory requires physical processes in the brain, chemical traces, neural activity. And those things only happen in one direction, as entropy increases. Then there's the causal arrow. Causes happen before effects. You flip a light switch and the light turns on, not the other way around. That's also due to entropy. Flipping the switch adds energy, which spreads out into the room. Order moves toward disorder. And finally, the cosmological arrow. The universe is expanding. Galaxies are moving away from each other, space itself is stretching, and everything is cooling over time. That outward flow gives a directional sense to the cosmos. Now, here's the curious part. All these arrows, entropy, memory, cause and effect, cosmic expansion, they all line up. They all point from the past to the future. That's not just convenient, it's reassuring. It hints that time isn't just an illusion, but something deeply built into the structure of reality. A direction carved by energy, by change, and by the spreading of everything from a once very tidy beginning. Still, not everyone agrees. Some physicists think the arrow of time might not be fundamental at all, that it's an emergent property, something that only shows up when complex beings like us observe simpler systems. Like watching tea cool or eggs scramble and thinking, ah yes, time is moving forward. In certain interpretations of quantum mechanics, time isn't a force or a flow at all. It's just a parameter, a label for different possible states. The universe doesn't feel time. We do. And that's the strange thing. No matter how deep we dig into entropy, statistics, or the equations that describe our universe, time remains elusive. It feels incredibly real. And yet, it might only exist as a story we tell ourselves to explain change. We ride time like a river, but we can't step outside it to look back or swim upstream. We can only keep going, moment by moment, with memory behind us and mystery ahead. So, the next time it feels like time is slipping through your fingers, remember, it isn't lost. It's just following the one rule it's really good at: moving forward, gathering entropy, leaving behind a trail of mismatched socks and empty teacups. Now, if classical physics treats time like a dependable train schedule, steadily ticking along, no surprises, then quantum physics has a very different approach. In the quantum world, time is more like jazz, unpredictable, improvised, mysterious. Sometimes it plays with dissonance, just to keep you guessing. It throws you a cat in a box and asks whether it's both alive and dead. Welcome to quantum mechanics, where reality becomes fuzzy, and time is more of a polite suggestion than a rigid rule. In the classical world, you can point to an object and say, it's right there doing that at this exact moment. But in the quantum realm, particles don't have neat positions or defined speeds. They exist as clouds of possibility, mathematical probabilities of where they might be or what they might be doing. So, where does time fit in? Surprisingly, not as much as you might think. Time in quantum mechanics shows up more as a background setting, something we plug into the equations to help things unfold. It's like hitting play on a simulation. The system evolves over time, but time itself just kind of hangs there in the background. Take the Schrödinger equation, the foundation of non-relativistic quantum mechanics. It describes how a quantum system's wave function, the mathematical cloud of potential outcomes, changes over time. But unlike Einstein's flexible spacetime, this version of time doesn't bend or stretch. It's fixed, silent, a stopwatch on the wall, never ticking louder or softer, just there. This creates an odd situation. On one hand, quantum mechanics describes how systems evolve with time. On the other, it doesn't tell us what time actually is. It simply assumes time exists, like a stage set in place before the actors arrive. Things get even stranger when you try to combine quantum mechanics with general relativity. These are the two great pillars of modern physics, but they don't always play nicely together. In relativity, space and time are dynamic. They bend, stretch, and respond to energy and mass. Time is part of the universe's fabric, but in quantum mechanics, time is fixed, unchanging, more like a cosmic conductor keeping a silent beat in the background. Trying to blend these two views is like choreographing ballet, using instructions from a heavy metal concert. This clash leads to what physicists call the problem of time in quantum gravity. When you try to describe the whole universe using quantum rules, space, matter, everything, you find something truly bizarre. Time disappears. There's an equation that pops up in this context, the Wheeler-DeWitt equation. It's a quantum version of describing the entire universe, but it doesn't contain any time variable at all. None. The equation is timeless. There's no past, no future, just a big eternal now. So what's happening? Is time even real? Or is it just a trick of how we experience change? Some scientists believe time is emergent, that it's not a basic building block of reality, but something that arises when you zoom out far enough. Like temperature. A single atom doesn't have a temperature, but put a lot of them together, and temperature becomes a useful idea. In the same way, time might not exist at the smallest scales. But when enough complexity builds up, it shows up as a helpful way to describe change. Others look to quantum entanglement, the strange phenomenon where two particles once linked can affect each other instantly, even across vast distances. Some theories suggest that the flow of time, and maybe even the arrow of time, could emerge from the growth of quantum entanglement. The more entangled the universe becomes, the more time seems to move forward. And then there's the many worlds interpretation. In this view, every quantum event, every measurement, every coin flip splits the universe into multiple branches. There's no randomness, just endless branching. Every possibility happens somewhere. Time in this view isn't a river. It's a vast, ever-branching tree. Each decision we make, every choice, every twist of fate creates another twig. Somewhere out there, there's a version of you who wore different socks this morning. But if time is so shaky at the quantum level, why does it feel so steady to us? Well, we live in a world where trillions of quantum events get averaged together into something that seems stable and predictable. Our brains, built from countless particles and circuits, are wired to perceive cause and effect. We wake up, brush our teeth, have breakfast, go to work, hopefully in that order. Time for us becomes a narrative, a way to organize change, a way to give meaning to motion. And storytelling, as it turns out, is something humans are especially good at. We link events into memories, we imagine what might come next, and we shape our identities through past, present, and future. Whether or not time is fundamental, we treat it as if it is. Still, quantum mechanics reminds us that beneath that familiar narrative lies something far more slippery. Time might not be the ticking of a clock or the flip of a calendar. It might be the unfolding of possibilities, the shift in probability, the gentle rhythm of reality reshaping itself every moment. So when your watch says it's 10 minutes to midnight, quantum physics gently whispers, well, yes, depending on your perspective. But time isn't just something tracked by satellites or whispered in quantum equations. It's also humming quietly inside you. It's in your cells, your sleep, your hunger, your mood. Whether you're a morning person, a night owl, or something groggily in between, your body runs on its own internal sense of time. And it's a very ancient one. This internal clock, or more precisely, network of clocks, is known as the circadian rhythm. The term comes from Latin, circa diem, meaning about a day. These biological cycles follow a roughly 24-hour pattern and regulate all sorts of things: when you feel tired, how your body digests food, even how you fight off illness. And they're not just found in humans. Pretty much every living thing on Earth, from plants to animals to fungi to some bacteria, has a version of a circadian rhythm. If something's alive and even mildly organized, chances are it knows what time it is. At the center of this biological timekeeping system is a tiny region in your brain called the suprachiasmatic nucleus, or SCN. It sits in the hypothalamus, just above where the optic nerves cross. That's a smart location, because it allows your brain to sync with light. When your eyes detect morning sunlight, the SCN receives the message and sends out signals to adjust your body, your temperature, hormone levels, even your mood. It's like your brain's personal assistant tapping its watch and saying, "Time to wake up." One of the SCN's key tasks is controlling melatonin, the hormone that helps you fall asleep. Melatonin levels rise in the evening, nudging you toward rest, and drop off in the morning to help you wake up. It's your body's way of saying, maybe don't start another movie right now. Whether you listen or not, well, that's another story. Here's an interesting twist. Your circadian rhythm doesn't run exactly 24 hours. For most people, it's slightly longer, about 24.2 hours. Left entirely to our own devices, like in a cave with no clocks or sunlight, we'd slowly drift out of sync with the actual day. That's why exposure to morning light is so important. It resets the clock. It keeps us anchored to the Earth's spin, or at least vaguely in sync with our morning alarms. When this delicate balance gets thrown off, strange things happen. Take jet lag, for example, everyone's least favorite travel souvenir. Jet lag occurs when your internal clock is suddenly out of step with the local environment. You fly across time zones and your brain thinks it's midnight when it's actually lunchtime. Your stomach, liver, and immune system get confused. Your body says, "Wait, why does this sandwich taste like jet fuel?" That's because different systems in your body adjust at different speeds. Your brain might catch on pretty quickly, but your digestive tract, it might still be living in yesterday's time zone. Another modern culprit is artificial light. Before electric bulbs, humans followed the sun. We woke up with daylight and got drowsy when it set. This natural rhythm still exists in traditional communities with little exposure to electricity. But now, we're surrounded by bright screens and glowing lights, especially blue light from phones, tablets, and TVs. That blue light tricks our brains into thinking it's still daytime. It suppresses melatonin, delays our sleep cycle, and pushes our internal rhythm later and later. It's not so much that we've become night owls. It's more like we've invited a neon owl into our bedrooms and handed it the remote control. Interestingly, not everyone's circadian rhythm is the same. Some people are naturally early risers, those cheerful larks who seem suspiciously full of energy at dawn. Others are owls, who hit their creative stride just as the rest of us are brushing our teeth. These tendencies are partly genetic, so if you're not a morning person, it might not be laziness. Your brain just doesn't believe it should be awake yet. And really, who are we to argue with evolution? Circadian rhythms influence more than just sleep. They affect your body temperature, which usually drops in the early morning and peaks in the late afternoon. That's why athletes and performers often do better later in the day. Their bodies are warmer, more alert, and operating at their best. It also explains why early morning meetings can feel like trying to solve math problems underwater. But biological time runs even deeper. It impacts your metabolism, your immune function, even how you respond to medicine. There's a growing field called chronopharmacology. It studies how the effectiveness of drugs changes depending on the time of day. Turns out, the same pill might work better in the morning or evening, depending on what it targets and how your body's systems are functioning at that moment. And this isn't just true for humans. Plants open their leaves during the day and fold them at night. They even prepare for sunrise, beginning to stir just before the light hits. This isn't simply a reaction to sunlight. It's an internal rhythm, one that keeps going even in constant darkness. Sunflowers don't turn toward the sun because they see it. They turn because they remember. And animals, from bees to birds to hibernating bears, all follow internal clocks that help them migrate, forage, and survive. Even fungi, those quiet forest dwellers, have internal rhythms that guide when they release spores or grow. All of this reveals something beautiful. Life on Earth doesn't just exist in time. It pulses with time. Not the kind measured by atomic clocks or digital watches, but a softer time. A biological rhythm grounded in light and dark, heat and cold, hunger and rest. So the next time you feel sluggish in the afternoon or oddly awake at midnight, know that it's not random. It's rhythm. Your body is dancing to an ancient, invisible beat, one that helped our ancestors survive, and one that still quietly guides us today through the glow of screens, the buzz of alarms, and the sleepy pull of evening. Even as we try to shape time with schedules and alarms, deep inside, we're still following the sun. Softly, steadily, faithfully. Have you ever noticed how time seems to play favorites? A holiday week disappears like a feather drifting on a breeze, but the final 10 minutes of a meeting you didn't want to attend in the first place. That can feel like getting slowly simmered in a pot of waiting. This isn't just poetic exaggeration. It's a demonstration of psychological time, our wonderfully strange internal way of experiencing the flow of moments, which often has very little to do with actual clocks or calendars. If physics is concerned with how time behaves, psychology is focused on how time feels, and those two are not always on speaking terms. Let's begin with perhaps the most well-known distortion. Time flies when you're having fun. As cliché as that sounds, it's surprisingly accurate. When we're deeply engaged, laughing with friends, immersed in a project, absorbed in something entertaining, our brains stop focusing on the clock. Our attention is fully directed at the experience itself, and time seems to vanish in the background. On the flip side, boredom makes time crawl. When nothing holds your interest, whether you're stuck in a line, sitting through a dull lecture, or waiting endlessly on hold, your brain becomes hyper-aware of time. You start noticing each passing second, and they seem to stretch longer and longer. There's also a fascinating divide between prospective and retrospective time. When you're living in the moment, time might feel fast or slow depending on how engaged you are. But when you look back on that same period, your perception might change. Let's say you spend a week exploring unfamiliar trails and sleeping under new skies. During the week, the days might zip by. But afterward, when you reflect, the trip feels long and full of vivid memories. Why? Because your brain created many mental bookmarks. Each new experience added another flag in your memory. So when you recall it later, it feels like more time must have passed. Compare that to a week where your days are routine. Wake, work, screen, sleep. That might have felt slow while living it, but in hindsight it becomes a blurry loop. Fewer bookmarks, fewer distinctive memories, less time in a way. This is one reason why time seems to speed up as we age. As children, everything is new. Our brains are constantly processing, learning, logging firsts. Our first bicycle ride, first heartbreak, first bizarre haircut. These moments are stored in sharp detail, but as we get older and fall into repetition, our brains don't bother storing everything. The highlights become sparser and time seems to compress. Emotion plays a powerful role too. When we're anxious or afraid, time often feels like it slows down. This isn't just dramatic storytelling, it's been observed in studies. People who experience sudden shocks, like bungee jumps or simulated free falls, often report feeling like time stretched, as if everything moved in slow motion. One explanation is that the brain goes into overdrive during such moments. It takes in more detail, stores more information. So when we recall that moment, it feels longer. Not because it actually lasted longer, but because there's more mental data. Interestingly, time doesn't actually slow during the event itself. People don't react faster or process better in real time. They just remember it as lasting longer. So while your mind insists, that was the longest roller coaster drop ever, your stopwatch might say, actually that was 3.2 seconds. Still impressive, just not Matrix level. Attention, perhaps more than anything else, shapes our sense of time. When we're focused on the ticking, waiting for cookies to bake, Watching the kettle boil, every tick is felt. But when our minds are elsewhere, reading, creating, playing, time fades into the background. This is closely connected to mindfulness and meditation. Practices that bring our attention into the present moment tend to soften or even dissolve our usual sense of time. It's not that we enter a trance or forget reality. It's that we stop measuring. We exist moment by moment without needing to assign a number to it. For many people, this brings a deep sense of peace. You're not rushing to the next thing. You're simply being. At the far end of the spectrum, there are altered states of consciousness. States triggered by deep meditation, intense emotion, or certain substances. People in these states sometimes report that time slows, loops, or disappears entirely. Some describe experiences of timelessness, not just stretched or bent time, but the complete absence of it. As if, just briefly, they stepped outside the river and stood on the bank watching it. Neurologically, these experiences may be tied to changes in a region of the brain known as the default mode network. This network is involved in self-referential thinking, memory, and time perception. When it quiets down, our usual sense of identity and time can dissolve, which might explain why some of our most timeless moments, moments of stillness, flow, also feel deeply meaningful. Children, too, have a unique relationship with time. For very young kids, time is soft, flexible, and often irrelevant. Ask a 5-year-old how long 5 minutes is, and you'll likely get an answer like forever, or until I'm done with my snack. Only as they grow and are introduced to schedules, clocks, and that dreaded phrase, just a few more minutes, do they begin to align with adult time. Some say that's when we lose a little bit of magic. Anticipation plays with time in interesting ways too. Looking forward to something, a vacation, a delivery, a reunion, can make time feel like it's dragging. We mentally rehearse the future, imagining what's to come. Likewise, dread can slow time. When we anticipate something we're nervous about, our minds fill with imagined scenarios and outcomes. That projection, like memory, consumes attention. And again, time stretches. Whether it's hope or anxiety, our minds create entire timelines before events even occur. So is psychological time reliable? Not really. Is it logical? Hardly. But is it deeply, beautifully human? Absolutely. We may live in a universe of atomic clocks, spinning planets, and gravitational equations, but the time we actually experience is made from memory, emotion, imagination, and attention. It's not time measured, it's time felt. And maybe that's why it feels so unpredictable, so wonderfully inconsistent, because at the end of the day, time isn't just a dimension, it's also a story. And we are its authors, writing, remembering, revising, one fleeting moment at a time. Let's take a moment now to zoom way, way out. Imagine drifting beyond the solar system, past galaxies, and into the wide, dark fabric of the cosmos itself. Here, time takes on a different scale, a different meaning altogether. When we talk about cosmic time, we're not dealing with minutes or hours. We're talking billions of years. The age of stars, the lifespans of galaxies, the slow dance of gravity sculpting the universe. According to our best current understanding, the universe is about 13.8 billion years old. That's the age of everything, from the oldest star clusters to the light reaching your eyes from distant galaxies, all measured using what we call cosmic time, the time that has passed since the Big Bang. But what does that even mean? Let's rewind farther than any human memory, to the moment of origin. The Big Bang wasn't an explosion in space. It was an expansion of space itself. Time and space began together in that moment, before it. There's no before, at least not in the way we usually think. Time itself began with the Big Bang, which leads to a wild question. If time began 13.8 billion years ago, how did it begin? And what was it like? Our earliest understanding of the universe comes from a moment just after the Big Bang, a fraction of a second when everything was unimaginably hot, dense, and rapidly expanding. In those first microseconds, the universe was too hot for atoms to form. Matter and energy were essentially one seething blur. Space expanded faster than the speed of light, not because anything was moving through space, but because space itself was stretching. As the universe cooled, things began to change. Particles formed. Forces separated. The building blocks of everything began to take shape. Eventually, light itself was freed. This is what we call the cosmic microwave background, the faint afterglow still visible today with special instruments. It's a snapshot of the young universe, around 380,000 years old. Since then, time has unfolded across unimaginable scales. Galaxies swirled into being, stars lit up, planets formed. Somewhere in the spiral arms of one galaxy, a blue planet cooled enough for life to begin. All of it marked by time, not as we count it, but in the slow, steady evolution of cosmic change. The expansion of the universe has continued ever since, and here's where it gets interesting. You may have heard of Hubble's law. Distant galaxies appear to be moving away from us, and the farther they are, the faster they recede. This isn't because we're at the center of the universe. It's because space itself is expanding, like dots on the surface of a balloon being inflated. The fabric of space is stretching. This expansion affects how we observe time. When we look at very distant galaxies, we're also looking back in time, because their light has taken billions of years to reach us. We see them not as they are now, but as they were when that light began its journey. This is what astronomers mean when they say telescopes are time machines. They show us the past, painted in photons. And here's another cosmic curiosity. The expansion of the universe is accelerating. This discovery, made in the late 1990s, stunned scientists. Instead of slowing down due to gravity, the expansion is speeding up. Something is pushing the universe apart faster and faster. We call it dark energy, not because we understand it, but because we don't. It makes up most of the energy in the universe, and yet its nature remains a mystery. But what does that mean for time? Well, as the universe expands, the clocks of distant galaxies tick differently from ours. Their light is redshifted, stretched to longer wavelengths. This isn't just a color shift, it's also a time shift. In extremely distant places, time may appear to move slower from our perspective, just as our own time might look slow to someone watching from across the cosmos. This relativistic effect, combined with cosmic expansion, paints a strange picture of time. There is no single universal now. Every part of the universe has its own clock, shaped by its motion, gravity, and place in the cosmic fabric. Which brings us to one of the most mysterious questions in all of cosmology. What is the ultimate fate of time? If the universe keeps expanding forever, will time go on forever too? Maybe. One possibility is the heat-death scenario. In this vision, the universe continues expanding until it becomes cold, dark, and uniform. Stars burn out. Galaxies fade. Everything spreads out so far that no new structures can form. In this distant future, entropy reaches a maximum. No energy gradients remain. No work can be done. It's not fiery or dramatic. It's quiet. A long, slow fade. Time in this version doesn't stop. It just becomes meaningless. There are no more clocks, no more change, just stillness. Another possibility is that time itself might be cyclic. Some theories suggest that the universe could collapse and bounce, expanding again in a new Big Bang. Time might reverse, reset, or even loop endlessly, a cosmic breath in and out. Others explore the idea that new universes might bud off from ours, each with their own time. A multiverse, not just of space, but of temporal realities. And some physicists believe time might not exist at all on the deepest level, that it's a product of our limited perspective, a pattern we impose on a much stranger, timeless reality. Each of these ideas stretches the imagination, and each reminds us the story of time is far from complete. We measure it in seconds, feel it in seasons, trace it in stars, but we are still learning what it truly is. We humans have always been storytellers, and time, perhaps more than anything else, is the thread that holds our stories together. Without time, there's no before or after, no growth, no memory, no meaning. Imagine a story without time. It would be a blur of disconnected images, no cause and effect, no character development, no beginning, middle, or end. That's why time feels so essential, not just to science, but to who we are. Our entire identity is wrapped around time. We remember being children. We imagine our future selves. We reflect. We hope. We regret. All of these are time-traveling acts of thought. Memory lets us relive the past. Imagination lets us preview what's to come. We shuttle back and forth across the timeline of our own minds, even while our bodies remain rooted in the now. And yet we don't experience time uniformly. We fragment it into hours, days, months, years, into calendars and time zones. We measure it with devices. We celebrate its milestones, birthdays, anniversaries, New Year's. We try to master time, manage it, save it, spend it. We fear wasting it, we chase it. And sometimes, if we're lucky, we forget it altogether. There's a kind of magic in those timeless moments, a walk at dusk, a shared laugh, the quiet stillness before sleep. These are the spaces where time softens, where its sharp edges blur and we simply exist. No plans, no deadlines, just being. Perhaps that's why stories are so powerful. They suspend time. They let us pause the world and enter another rhythm, one that unfolds at the pace of emotion, not obligation. In stories, a second can stretch across pages, or decades can pass in a single line, just like in dreams. Dreams, too, play tricks with time. You might fall asleep and within a few minutes experience an elaborate story that feels like it lasted hours. Your brain, untethered from real-world clocks, creates its own timelines. In dreams, time becomes elastic. Symbols replace seconds. Emotion replaces duration. And when you wake, it can be hard to say how long you were really gone. In a way, that's true for life itself. We wake each morning into a world of time. We rise with alarms, plan our days, count the hours, but deep inside we carry a second clock, an inner metronome shaped not by seconds but by stories, by memories, by meaning. A song can transport us to a forgotten moment. A scent can bring back a childhood afternoon. A photograph can open a door to the past so vivid it almost feels like stepping through. That's not just nostalgia. That's time travel of the most human kind. We also tell time through our bodies, through the slow changes we witness in the mirror, through the laughter lines, the silver threads, the way our voices deepen or soften. Our bodies remember time in ways our minds can't always measure. Each heartbeat, each breath, each night of rest or restless turning is a marker, a rhythm, a reminder. Some cultures view time not as a line but as a cycle. Time returns. The seasons loop. The moon waxes and wanes. Life, death, rebirth. Again and again. This view isn't wrong, it's just different. And maybe in some ways it's more soothing. Because if time is a cycle, then nothing is ever really gone, only transformed, only waiting to return. In Western culture, time often feels like a race, a resource to be optimized, something slipping away. But in other traditions, time is a presence, a companion, a teacher. It doesn't rush. It doesn't demand, it simply is. This contrast shapes everything, from how we work to how we rest to how we think about aging. In many indigenous communities, elders are not seen as running out of time. They are seen as full of it, full of stories, wisdom, and lived moments. Age becomes depth, not decline, and time, instead of a vanishing currency, becomes a deepening well. This idea of time as something that accumulates rather than disappears is a gentle shift in perspective, one that can soften our relationship with it, because we often feel pressure about time, that we should be doing more, that we're falling behind, that we're late to something, whether it's success, love, healing, or happiness. But time isn't a competition. There is no final scoreboard, no universal schedule to meet. Your time is your own, and the pace of your life is not wrong. You are not behind. You are simply on your path. Even the stars take time. They burn for billions of years. They flicker into being, shine brightly, and eventually fade. And still, they're not late. They're on stellar time. So what if we treated ourselves with that same gentleness? What if we moved through time not as something to conquer, but something to experience? Not as a ticking deadline, but as a river to float in. To notice the light, the ripples, the leaves passing by. To feel the warmth of a moment before it flows into the next. We speak often about being in the moment. But maybe it's less about capturing the moment and more about letting it unfold, trusting that another will follow, and another, and another, until one day we look back not with regret but with quiet awe at the tapestry of time we've lived, each thread a memory, each color a feeling, each knot a turning point, and woven through all of it softly, steadily, the time we spent simply being. Now let's take a breath, a long, quiet one, because it's easy to talk about time and forget to feel it, to get lost in theories, equations, cosmic scales, and still miss the heartbeat happening right here. This moment, this breath, this pause between words, that's time too, not the measured kind, not the scientific or philosophical kind, but the lived kind, the kind of time that softens when you're safe, that stretches when you're at peace, that deepens when you're present. This kind of time doesn't demand explanation. It doesn't need to be solved, only noticed. And that's something modern life often forgets. In our rush to optimize everything, our schedules, our productivity, even our rest, we sometimes lose the quiet moments, the in-between ones, the ones where nothing is happening and yet everything is, like the silence before a song starts, the stillness before a kiss, the hush before the sun rises. Those are moments that can't be timed. They can only be felt. And perhaps those are the moments that time was made for. In meditation traditions, this is often called the eternal now, a space where time stops, not because it breaks, but because you step outside of your usual rush. You're not remembering the past. You're not planning the future. You're simply here, present, breathing, aware. It's not easy to stay there. The mind loves to wander, to rehash old conversations or fast forward to imaginary worries. But sometimes, just for a second, we catch it. That sensation of stillness, of just being. No need to measure it. That's the kind of time you can't capture with a stopwatch. But it stays with you, gently echoing like a distant bell. Some people call these sacred moments. Others call them mindful, or meaningful, or simply peaceful. Whatever name you give them, they remind us that time is not always something to track. Sometimes it's something to trust, to let unfold, to move through us instead of us racing through it. And speaking of trust, there's something soothing in knowing that even though we don't fully understand time, it still carries us. It keeps moving moment by moment, whether we worry or not. It holds our memories, our healing, our growth, sometimes slowly, sometimes all at once, but always, always moving. Even in the hard times, especially in the hard times, it helps to remember this. Nothing lasts forever. Not joy, not sorrow, not uncertainty. Time keeps flowing, and with it so do we. In this way, time is a kind of comfort, a promise that every storm will pass, that every night becomes morning, that healing, though never rushed, will come. We mark time in many ways, through birthdays, through sunsets, through seasons changing, through the way a child outgrows a favorite sweater, through laughter lines forming near the eyes, even through loss. Grief, too, is a way of feeling time. It reminds us of how deeply we've loved and how deeply we continue to carry that love. Time doesn't take that away. It transforms it, shapes it, softens the edges without erasing the memory. And as we age, time stops being something that stretches endlessly in front of us. It becomes something we begin to see in reverse, not just in what's coming, but in what's been. And here's the beautiful thing. That perspective makes moments more precious. We begin to notice the small things, the ordinary magic, the sound of a loved one's voice, the way sunlight filters through a window, the warmth of a blanket on a cold evening. Time teaches us gratitude if we let it. It reminds us that nothing is guaranteed, that presence is a gift, that today was never promised but it arrived anyway. And tomorrow, well, maybe it will come, maybe it won't. But this moment is here, and for now that's enough. There's a quiet truth that poets, scientists, monks, and philosophers all seem to circle around. We don't just live in time. Time lives in us. It's in our breath, our dreams, our words. Every second you've ever lived still echoes within you in some way. And every second you will live is already shaped by who you are right now. Time isn't something we chase. It's something we create through what we choose, how we feel, and where we give our attention. So if you ever feel like time is slipping away, remember, it always was. That's what makes it so precious. But also remember this, you're part of it. You're not standing outside of time trying to catch it. You're flowing with it like a river in the current. You're not behind, you're not ahead. You're exactly where you need to be, right here, right now, in time, with time, of time. Somewhere along the way, we began to think of time as something to manage, to break into blocks, to fill with tasks, to squeeze until there's nothing left. We schedule every minute, color code our calendars, count the days until the weekend. And sometimes we forget what those days are even for. But time wasn't always like this. Once upon a time, it was measured by the arc of the sun, by the call of birds, by hunger, by the tilt of the stars. Before the invention of clocks, people lived closer to natural rhythms. They rose with light, worked with their hands, rested when the day dimmed. There was no 9 to 5, no inbox overflowing, no time zones or alarms or blinking reminders. And yet life moved forward. Children were born, fields were planted, stories were passed from one fire to another. That kind of time wasn't less real, it was simply less rigid. Mechanical time, as we know it, is a human creation, a useful one, of course. We needed trains to arrive on time, factories to run efficiently, global networks to stay in sync. But as the clock grew louder, natural time grew quiet. We began to feel guilt for resting, anxiety for pausing. We learned to equate busy with worthy, and stillness with waste. But what if we remembered a different way? What if time could be something we moved with, not against? Some cultures still hold this truth close. In parts of the world, time isn't seen as something to fight, but something to respect. There's time for planting, time for harvesting, time for speaking, time for listening. And when something takes longer than expected, it isn't a failure. It's just life unfolding. There's a term in some indigenous cultures, time as belonging. It means you're not late, you're not early, you're arriving exactly when you're supposed to, because time is not just a number, it's a relationship. You don't own time, you're part of it. And when you treat it with care, it treats you gently in return. Even language shows us how differently time can be understood. In English, we spend time like money. In other languages, time is passed with or shared. Not a currency, but a presence. Imagine how that might change how we live. Instead of trying to buy more time, we might simply learn to be with it, to sit beside it, to ask gently, "What do you need from me today?" Time becomes not something we race, but something we accompany. Not a ticking threat, but a silent companion, one that says, "I'll go with you if you let me." It's not easy to shift how we think about time. The world is fast and we are asked to keep up. But even in the speed, there are pauses. Even in the rush, there are rests, tiny windows, small moments, little invitations to slow down, to look out a window, to feel the weight of a breath, to close your eyes for a beat longer than usual. These are acts of rebellion, of remembering. That life isn't made in the hustle, it's found in the spaces between. And in those spaces, something beautiful grows: awareness, gratitude, wonder. The kinds of things that don't fit neatly in a planner, but that hold the most meaning when you look back later and think, that moment, that was real. Because time isn't just passing, it's shaping. It's sculpting you gently like water shaping stone. You may not notice the changes day by day, but over years, they're there, in your patience, in your softness, in your understanding, in the way you listen or pause or hold space for someone else. That's time working in you, not as a deadline, but as a guide. And if that's true, if time is shaping us, then how we relate to it matters. How we speak about it, how we treat it, how we share it with others. We often say things like, "I don't have time," or "time got away from me." But maybe time isn't the thief. Maybe it's just waiting for us to notice it, to greet it, to walk with it, not run ahead. The sleepy narrator invites you, just for tonight, to release the need to be on time, to stop counting minutes, to stop measuring your worth in tasks completed or emails sent, and instead to settle into a deeper rhythm, the one that hums beneath the clock, the one that says, "You're okay, you're here, this moment is enough." Because it is. You don't need to do anything else right now. You don't need to catch up. You don't need to prove anything. You're breathing. You're listening. You're part of the rhythm of time just as you are, and that's more than enough. So, as this day fades, and whether your clock says it's early or late, let time soften its grip. Let it wrap around you like a blanket. Let it slow. You're not behind, you're not ahead. You're exactly where time meant for you to be. And time, it's right here with you, quiet, kind, unfolding, always. Now let's shift our focus again, from the personal to the cosmic, from the inner beat of our own lives to the larger structure of time across civilizations. Because while we each feel time individually, through our thoughts, habits, and emotions, humanity as a whole has also shaped time collectively. Over the centuries, we've built elaborate systems to keep track of time. We've aligned ourselves with the stars, created calendars, invented tools to measure, and even argued about what day it really is. It all started with observation. Long before wristwatches or wall clocks, people studied the sky, the cycles of the moon, the rise and fall of constellations, the patterns of the sun. These rhythms gave rise to our earliest calendars. The moon waxed and waned, guiding months. The sun moved through seasons, guiding planting and harvesting. The stars marked deeper cycles, longer years, repeating alignments, cosmic patterns that told stories in the sky. Ancient civilizations tracked time in astonishing ways. The Babylonians divided the day into hours using sundials. They also introduced the base 60 system, which is why we have 60 seconds in a minute and 60 minutes in an hour. The Egyptians used water clocks and star charts. Their observations of Sirius rising before dawn helped predict the flooding of the Nile, a vital event for their agriculture. The Mayans had multiple calendars operating at once, a sacred 260-day cycle and a solar 365-day calendar. They used both together to mark ceremonial and agricultural time. They even calculated lunar and planetary cycles with impressive accuracy. Meanwhile, in ancient China, astronomers recorded eclipses and used star maps to align time with dynastic rule. In every culture, time was tied to power, order, and ritual. To understand time was to understand the cosmos. And to control time, through calendars, clocks, and proclamations, was to hold influence over society. Eventually, as societies became more complex, we needed more precision. Enter mechanical clocks. The first mechanical clocks appeared in medieval Europe, usually in monasteries to regulate prayer times. They didn't have faces at first, only bells that rang out at regular intervals. These bells shaped communal time. They told people when to work, when to eat, when to pray, when to rest. As clock towers spread, so did a shared sense of schedule. And when trade and travel increased, so did the need for coordination. Merchants needed to agree on meeting times. Sailors needed precise navigation. Cities needed schedules. Time became more standardized and more mechanical. Then came the Industrial Revolution, and time took on an entirely new role. Factories required shifts. Machines ran on schedules. Trains ran on timetables. Suddenly, being on time wasn't just polite, it was essential. In the 19th century, the invention of the telegraph and expansion of railroads led to the creation of time zones. Before this, each town kept its own local time based on the sun. But that became chaotic for travel and communication. So, in 1884, representatives from around the world met in Washington, D.C. They divided the Earth into 24 time zones and established the prime meridian at Greenwich, England. It was a moment that changed timekeeping forever. Now, the world could synchronize, or at least try. Today, we rarely think about time zones. Our phones and computers adjust automatically. But underneath that convenience lies an intricate system, constantly maintained by signals, servers, and atomic clocks. Speaking of which, atomic time is now our most accurate measure. An atomic clock uses the vibrations of atoms, usually cesium or rubidium, to measure seconds with stunning precision. So precise, in fact, that they would only lose a second every few 100 million years. These clocks help synchronize GPS satellites, global financial systems, and communication networks. They're the heartbeat of the modern world, invisible but essential. And yet, even with all this accuracy, time remains slippery in practice. We add leap seconds to atomic time to keep it aligned with the Earth's slightly irregular rotation. Because Earth, it turns out, isn't a perfect timekeeper. It wobbles, it slows, it shifts. So once in a while, we pause all the world's clocks just for a second to stay in sync with the planet. Time, for all our efforts to master it, still has a little wildness left. And in that wildness, there's a quiet reminder. Time isn't just ours to define. It's something we move with, something we respond to, something we live inside. Even our calendars, the most basic way we track time, are full of strange compromises. The Gregorian calendar, the one most of the world uses today, was introduced by Pope Gregory XIII in 1582 to correct inaccuracies in the older Julian calendar. It made small adjustments to leap years to keep the calendar aligned with the solar year. But even so, it's not perfect. A year isn't exactly 365.25 days. It's a little less. Which is why every few centuries we skip a leap year to balance things out. And our months, well, they're a mix of lunar and solar traditions. Some with 30 days, some with 31, one with 28 or 29 if it's a leap year. It's not perfectly logical, but it works. Mostly. Timekeeping, like so many human systems, is a blend of science, culture, tradition, and compromise. And maybe that's fitting. Because time itself, despite our best definitions, resists being pinned down. We live in the most precisely timed era in history. We can measure nanoseconds. We can synchronize satellites. We can send probes billions of miles and have them arrive within minutes of expectation. And yet, we still forget what day it is. We still feel like days stretch or shrink. We still wonder where the time went. All our precision hasn't erased the mystery. And maybe it shouldn't. Maybe time isn't something we're meant to solve, but something we're meant to live. Because no matter how many clocks we build, no matter how accurately we measure, time is and always will be something we feel. We feel it in the space between words, in the pause before a decision, in the moment before sleep. We feel it in aging faces, in growing children, in the way memories ripple across the mind like leaves on water. Time isn't just numbers on a screen. It's laughter that echoes longer than the moment it began. It's grief that stays long after the moment has passed. It's love that stretches across years, cities, and lifetimes. Time is the invisible companion walking beside us always, sometimes unnoticed, sometimes overwhelming. It comforts us when it softens pain. It unsettles us when it feels out of control. It frustrates us when we feel rushed. It delights us when we lose track of it doing something we enjoy. And somehow, all of that is true at once. Time is strange, but maybe that's what makes it beautiful, because time is not a straight line. It loops, it lingers. It returns in dreams, in déjà vu, in the way old songs stir something we thought was forgotten. Some memories are so vivid they feel like now. Some plans are so alive they pull us forward as if the future is already reaching back. In those moments, time folds. Not scientifically, maybe, but emotionally, spiritually, experientially. We hold entire years in a single sigh. We stretch a second into something sacred. We carry time within us. And yet, for all its depth, time also disappears. It slips quietly like water through fingers. We make plans, we count days, and then suddenly it's another season, another year, another story begun. Which is why presence matters so much, because presence is how we meet time, how we acknowledge it, How we say, yes, I am here for this. Whether it's a cup of tea, a shared silence, or a new beginning, presence is how we mark what matters. So many of our most meaningful moments aren't the ones we scheduled. They're the ones that happen between appointments, in the gaps, in the quiet, in the pauses. We don't always remember the date or the hour, but we remember how it felt, how time stood still for just a moment, how we knew deep in our bones, this matters. Time, in that way, is not just a measure, it's a mirror. It reflects what we care about, what we long for, what we remember. And sometimes it invites us to return to a feeling, a place, a truth, not by turning back the clock but by stepping into a familiar rhythm, by doing something slowly, by noticing something ordinary, by choosing to be here not just physically but fully. The more we practice that, the more time seems to expand. Not in quantity, but in quality. We stop racing. We start noticing. We begin to belong to our own lives again. That's the kind of time the sleepy narrator believes in. Not rushed, not squeezed, but savored. The kind of time that lets stories breathe, that lets silence speak, that lets dreams unfold without deadlines. Because some truths don't reveal themselves right away. They need room, they need slowness, they need time, and when we give them that time, something shifts. We stop treating moments as stepping stones, and we start seeing them as destinations. This moment isn't just a bridge to the next one, it's a place to arrive, to settle in, to say, I'm here. And that changes everything. Because when you stop racing time, you start walking with it. You notice its rhythm, you hear its quiet music. You realize it's not working against you. It's always been moving with you, even when it felt too fast, even when it felt too slow, even when it felt like it vanished altogether. Time was still there, holding you, waiting for you, willing to begin again whenever you are. And maybe that's the most hopeful thing of all. That time is not just a force or a fact, it's a friend, one that forgives, one that offers another chance. One that gently says it's not too late to rest, to begin again, to return, to let go, to become something new, or simply to be. Time doesn't ask us to be perfect. It just asks us to be present, to notice, to feel, to live, and maybe to wonder. Because when we wonder, we stretch time, we open it, we fill it with curiosity instead of worry. And that is a beautiful way to spend it. So as you listen to this now, whether at the end of your day or deep into the night, take one more moment. A real one, a breath, a stillness, a space, to remember that you are not running out of time. You are living in it, shaped by it, part of it. And it is holding you gently, right now. Time, in the end, is many things. It's a mystery, a measurement, a movement, a feeling. It's the ticking of seconds and the softness of seasons. It's the structure of the cosmos and the rhythm of a heartbeat. It's both science and story, both the map and the journey. And though we try to understand it, organize it, even master it, the truth is, time is not something to be controlled. It's something to be in relationship with. Some days it will rush, others it will slow. Some moments will pass like wind, others will press themselves into your memory like ink on a page. And through all of that, you will keep living inside time, breathing in it, learning from it, growing with it. That's the wonder of being human. We are not just observers of time, we are participants, carriers of time in our minds, in our cells, in our stories. Every scar, every smile, every quiet victory, time was there. Not watching from a distance, but dancing beside you. Even now, even here, especially here. Because this moment you're in, it's never happened before, and it will never happen again. It's unique, unrepeatable, yours, and just like all the others, it will pass, but not before it leaves something behind. Maybe a thought, maybe a breath, maybe a subtle shift in how you see the world. And so the story of time continues. Not just through textbooks or telescopes, but through you, through how you live, through how you notice, through how you care. You are part of the great unfolding, a chapter in the timeline, a flicker in the cosmic clock, and yet completely irreplaceable. Your time is not small, it's sacred. It matters. Not because of what you accomplish or how many things you check off, but because you are here, feeling it, being it, becoming through it. And if time teaches us anything, it's this: nothing stays, but everything shapes. The fleeting is not empty. It's full of movement, meaning, and memory. The most delicate moments often carry the deepest truths: a tear at the right time, a word held just long enough, a glance that changes everything. Time weaves these into the fabric of your life, not as decoration, but as structure. The moments you think are too small to matter, they are the ones doing the quiet work, the slow carving, the gentle sculpting. And one day you'll look back, not at a blur, but at a mosaic, full of detail, full of time. And you'll see that even when you thought you were lost, you were becoming, you were arriving, you were exactly where you needed to be. That's the secret time never says aloud, but always whispers. You're not behind, you're not too late. You're simply becoming. In your own rhythm, in your own unfolding, in your own time. And that time, it belongs to you, even as you share it with others, even as it joins the collective story, even as it melts into memory. It is still yours. It shaped your hands, it carried your voice. It gave you chances, some you missed, some you took, some still waiting. And it's not done, not yet, because you're still here, still listening, still wondering, still breathing. And wherever you are in your journey, time is walking beside you. Not ahead, not behind, but with you, step for step, moment by moment, always unfolding. So where does this leave us? After all this exploring through the physics, the psychology, the biology, the memory, the rhythm, what can we say time truly is? Is it a dimension woven into the structure of the universe? Is it an illusion born from consciousness? Is it a ticking mechanism, a flowing river, a trick of entropy, a gift? Maybe it's all of these, and maybe none. Maybe time is something we will never fully capture in a sentence, only in sensation. Because even when we know how to measure it, time still surprises us. Even when we understand the theory, time still bends. Even when we follow the schedule, time still escapes. And even when we believe we've run out of time, life keeps finding new ways to begin again. Maybe time isn't meant to be solved, but softened. Maybe it's less like an equation and more like a poem. One that never rhymes the same way twice. One that always ends but never really finishes. And maybe the best we can do is walk with it. Not ahead, not behind, but with time. To listen when it speaks. To rest when it's quiet. To move when it nudges. To stay still when it waits. Because time waits too, you know. Not always in clocks, but in the hush before morning, in the breath before an answer, in the gentle hand you almost reached for but paused and then did. Time lives in those moments too, the ones we often call small or nothing special, the ones we sometimes miss while we chase the big ones. But time is not just in milestones, it's in the in-betweens, in the way someone says your name, in the flicker of light on water, in the laugh that arrives unexpectedly. And sometimes, the most sacred kind of time is not the kind you remember, but the kind you didn't even notice until it was already part of you. So if you're asking, what should I do with my time? Perhaps the answer is simpler than it seems. Be in it, feel it, let it carry you, and whenever you can, let it slow. Not every moment needs to be filled. Not every second needs to be stretched. Some can simply be. And those moments often are the ones that return to us when we least expect it, not as data or deadlines, but as warmth, as stillness, as peace. So tonight, as you rest, as you drift, as you let go of this day, know that time is still here, not rushing, not judging, just unfolding. You don't need to catch up. You don't need to rewind. You don't need to fast forward. This moment right here is enough. It holds everything you've ever been and everything you're still becoming. Let time soften around you now. Let it cradle you gently. Let it breathe with you, because tomorrow will come. And it will bring its own rhythm. And you'll meet it when it arrives, exactly as you are, exactly in your time. So as we bring this journey to a close, let's return once more to the heart of it all. Not the math, not the mechanics, not even the mysteries, but the experience. Because no matter what science says, no matter what theories come and go, you are here, right now, inside a moment that only you can live. Time surrounds you, shapes you, moves through you. and you in return shape it, with your attention, your choices, your presence. Every time you pause to notice, every time you choose to be still, every time you say, "This matters," you are not just spending time, you're creating meaning. And that is one of the most human things we can do, to take a moment and give it weight, to take an ordinary second and let it become sacred. That is the kind of time clocks cannot measure. That is the kind of time you carry with you. So, what is time really? Maybe it's a question. Maybe it's an answer. Maybe it's both. But tonight, maybe it's also something simpler, a quiet rhythm, a warm presence, a gentle reminder that nothing is permanent and yet everything leaves a trace. Maybe time is this, the hush in your breath, the warmth in your chest, the feeling that just for now everything is okay, and that wherever you are, whatever hour it is, you're allowed to rest. You're allowed to drift, to let go, to simply exist in the cradle of this moment. Because time will keep going. It always does. But for now, it's slowing with you, waiting with you, breathing with you. So if your eyes are growing heavy, if your thoughts are softening, if your body is sinking deeper into stillness, let time hold you. Let the day fall behind. Let tomorrow stay where it is. Let your mind find silence. There is nothing more to do, nothing more to fix, nothing more to figure out. Time is doing its part, and you are doing yours by simply being here. Now that is enough. You are enough. The sleepy narrator is so grateful to have shared this space with you. This pause, this reflection, this little stretch of time just for you. May your dreams be soft. May your rest be deep. And may you wake with a sense of wonder, not just for the hours ahead, but for the mystery you carry within you. Because you, like time, are always unfolding, always becoming, and always beautifully here. Good night. And thank you for your time.